what group does the question mark sample belongs to and why? And now, to what group does the question mark sample belongs to and why? This exercise was designed to show you that the mathematical concept of distance is way more wide than our everyday use of the concept of distance, which is just based on location. In mathematical terms, what we're doing when we talk about distance is quantifying the difference in various measurements. A distance is just a metric. This metric is always positive, and therefore the minimum value of the distance of a distance is 0. And in fact, if the distance between 2 points x and y is 0, then both points fall within the same they are equal. They fall exactly within the same spatial location. And then space, in terms of the different characteristics that were measured, that may have absolutely nothing to do with the spatial location in terms of what we manage every day. A distance has the property of symmetry, meaning that the distance between points x and y is the same as the distance between y and x. And they meet the triangle inequality, which is to say that the distance between the points x and z is always smaller or equal than the distance between x and intermediate point y plus the distance between y and z. You can see a graphical representation of the triangle inequality to the right-hand side of the slide. There are different types of distances. Just to name a few, the Euclidean distance is the most intuitive of them all because this is the one that we, again, typically use when we talk about distance in our everyday life. The Mahalanobis distance is very similar to the Euclidean distance, but it accounts for the dispersion and uneven dispersion of the data across the different dimensions. And then we have the cosine distance, which basically measures the angle of the vectors of 2 points. Then we have Manhattan and Hamming distances, which are intended for binary data. Then we have the Minkowski, which is just one that, it has a parameter there that based on the value of the parameter, we can create other distances, such as the Euclidean, for example, or the Manhattan. So distance-based classifiers use this distance metric to quantify the difference between a new sample and other samples seen during training. And then based on that metric, based on that measurement, make a decision on which class does the new sample correspond to.